If I ask you to think about AI, what image would come into your mind? Some people will think about some humanoid-like robots from Black Mirror series, or some people will think about Marvel Jarvis AI assistant of the Iron Man, or some people will think about the hundreds of thousands of millions of lines of code passing through your PC. But today, what's happening is that more and more people will think about AI as a ChatGPT or Gemini, any chatbot, and we've got a handful of them around us. But what if I tell you that these science fiction movies are much closer to the original definition of artificial intelligence, and the ChatGPT is just a text generation model that acts like a human but is not actually artificial intelligence? What is AI? What is the difference between AI and machine learning? And where's the borderline? Let's talk about this in this video. Let's start with a simple computer program. Actually, it's just a list of instructions of how to take input data, transform it according to some internal logic, and then produce the output. If the logic is not too complex or can be known in advance, then just making such a tree of those if and else statements would be the best call. Of course, you can apply some fancy software engineering patterns. In the end, it will still be a list of if and else statements, and this behavior is known well in advance before the program is put into production. What if we don't know exactly every single rule that we have to apply to achieve the result, and we have a historical set of data that we can use to learn to derive those rules for us? In this case, we can use machine learning algorithm. Basically, in this case, we will feed previously known data to the algorithm, and it will derive all the conditions and all the decision trees for us. And it's possible that there will not be only one decision tree, there might be so many of them. However, the final result will be defined as an interpretations of those decision trees that have been trained using the input data. In this case, we don't specifically say what are the conditions or what is the protocol we want the program to follow. The only thing that we can define is the hyperparameters of the machine learning algorithm. We can tell it which features should it use, which can tell it which target variable, if there is a target variable, should it use, which metric should it use when it trains, and so on and so forth. If we correctly set up all the parameters, we fed in the right training data, and we fed in the right target variable, though the algorithm will train it for us. But what if we have relatively structured data, I don't know, some text or some tables or some images, but we don't know which exact features should be used to solve a problem, how they should be transformed? Of course, there's always an option to try out a bunch of combinations and see which work best, but eventually we will reach some limit. Either we will be limited by time or computational cost or just patience. But what if we don't know which exact features should be used in order to solve a problem? I mean, our input is relatively structured. We know what we want to achieve, but we don't know which features should we take, how to process those features. In this case, you will need to use neural networks. The more I use them, the more I admire the elegancy of this solution. And this year, we can finally celebrate that two people who made fundamental contribution to development of neural networks got their Nobel Prize in physics. Even though they did not create ChatGPT or DALL-E, but without their fundamental discoveries, none of them would be possible. John Hopfield created the concept of associated memory. Without going into much details, the way it works is inspired by human brain, and that makes it very flexible and allows storing and restoring very complex information from a generalized versions of it. That's the way how humans remember things, right? Because we don't remember every single details about what has happened in the past, but rather we have some flashlights in our brain that allow us to restore what has happened in the past. Geoffrey Hinton made a significant contribution to the backpropagation algorithms. In a nutshell, it works in a very similar way like human brain works when it's training. And this method allows multi-layer neural networks to train and learn from the data that is fed into that. In this case, we can no longer define which features the model should be using, but the only thing we can define is the number and the characteristics of connections between different neurons, which transform the input data to the desired output. During the training, the neural network will yield a sample from the training data, will make predictions, will check by how much it has missed, and depending on how much it has missed, it will try to update all the parameters of the network to minimize the error in the future. And this process will continue over and over again until the model breaches the state with the least possible error. Going back to the original question, what is AI and where is the difference with machine learning? I can say that from my point of view, neural networks today are the closest we have ever been to the real artificial intelligence. However, a program that is not able to understand that there is a world outside the boundaries of the problem. So they can be super good in solving one specific task, but they will not be able to realize that this task may be useless. They are not able to realize that there are other more important tasks that have to be solved. That's why people in sci-fi movies talking about Skynet or Jarvis or other very smart technologies, they are much closer to the actual definition of AI. But however, in modern world, of course, a lot of people will call ChatGPT an AI, whereas it is a simple text generation program. Anyways, thanks a lot for watching and hope you enjoyed this video. Please don't forget to like and subscribe.